Hello everyone, my name is Vishal Kumar Sharma and I am currently pursuing B.Tech from Galgota University and I am currently living in Ghaziabad, Uttar Pradesh. My project title name is Heart Disease Prediction using Machine Learning. I am passionate about exploring the field of artificial intelligence in the medical field. By working on this project, my project goal is to predict accurately a person suffer from heart disease or not, and my project ID is IJEAS1202002. Now let's go to our research paper.
So let us start with the presentation of our research paper. So our title is Heart Disease Prediction Using Machine Learning, and the authors are Vishal Kumar Sharma, Aviral Sivaj, and Miss Arpan Kumari is our guide. So let us start with the abstract of the research paper. It is one of the most challenging tasks in the medicine to forecast the prevalence of cardiovascular disease. Nearly 1% dies from cardiovascular disease per minute these days. Data science is also essential for healthcare companies to manage large data sets. Because predicting cardiac sickness is so difficult, automating the prediction process is vital for reducing risk and notifying patients early. The UCI machine learning repository has a dataset pertaining to cardiac disease that was utilized in this work. In order to assess the likelihood of cardiovascular disease and categorize patients' risk levels, the proposed study employs a number of data mining methods including naive Bayes, decision tree, and logistic regression. Now moving forward to the index terms used, some of them are decision tree, naive Bayes, logistic regression, random forest, and heart disease prediction. Now moving on to the introduction, the discovery of data mining algorithms that are capable of predicting the start of cardiac disease is the fundamental purpose of this study. There is a possibility that other areas of the body will become alerted when the heart is not pumping blood adequately. Both leading a healthy lifestyle and recognizing potential heart problems at an early stage are the only methods to avoid them. Modern healthcare has a number of challenges, two of the most serious of which are ensuring accurate diagnosis and providing effective treatments. Now, moving on to the related work. Utilizing the UCI machine learning dataset for the purpose of predicting cardiac sickness has been the subject of a significant amount of study. Data recognition algorithms such as decision tree, KNN, and K-means were evaluated by researchers on page 1 to see how effectively they identify data. Now moving forward comes the generic model predicting heart disease. So here is the flow chart of it. Begin data collection, data pre-processing, classification, then splitting into training data and testing data, and then classification techniques, test the model, result, and then end. Here are some values of the algorithms: precision, recall, F measure, accuracy. In algorithms we have three of them: decision tree, logistic regression, and random forest. Here are the values of the different algorithms. Now coming on to the different models. So first comes the random forest classification. Random forest methods, in order to make predictions, it builds data even when there aren't a ton of variables to work with. The random forest method can nevertheless provide reliable findings on large data sets. Further comes decision tree. A flowchart represents the decision tree algorithm. Logistic regression. Logistic regression is a classification algorithm mostly used for binary classification problems. Here is the table of the same. The table is of values obtained for confusion matrix using different algorithms. Then comes the conclusion. Given the rising number of deaths that are attributed to cardiac problems, it is of the utmost importance to devise a strategy that is both accurate and efficient in anticipating cardiac problems. For the purpose of this investigation, the dataset from the UCI machine learning repository is utilized to investigate the accuracy of several algorithms. Then comes the references. Thank you.